Right. I think I've got this ready to go. We'll find out. Today we're going to be doing Algebra 2 lecture for worksheet 1012 and 1013. It's OASA 2A11 again. The student will solve quadratic equations by factoring. In this case, we're going to run into a situation where we have to use the zero product property. And the zero product property says that if you have any two factors, the factors are things that are multiplied together. If we have two things that are multiplied together and we get zero, then either this one is zero or this one is zero. If A times B is zero, one of these has to be zero. That's the zero product property. And that's what we're going to be using to solve quadratic equations. We're going to have a quadratic trinomial that we've been working with in the past. It might be a binomial, two terms, but it's going to be in an equation, and we're going to solve that using factoring. We're going to say, well, if we have it factored and these two factors equal zero, the product of these two factors is zero, one of these factors has to equal zero. That's what we're going to do. So here's what it's going to look like. Solve by factoring. I have an equation now. What I want to do is get all of my variable terms and constants on one side of the equation and have a zero on the other side. So what I'm going to do in this situation, I always want my quadratic term, that's the variable term that has the second power, I want it to be positive. And in today's lecture, they're always going to be positive to begin with. And I want to get everything else that's on the other side of the equal sign to the same side as the v squared. In other words, we're going to turn this into zero by adding 18 and adding 9v. That will turn this to zero. In order to do that, I've got to add 9v and 18 on this side. So that's what this is. Here's what this is going to look like. That turns the negative 18 into zero. This turns 9v into zero. So this side of the equation is 9, 0. Over here, I've got to do the exact same thing. I've got to add 18 and 9v. When I rewrite this side of the equation, I'm going to put it in what's called standard form. I'm going to write the highest power of v, that's v squared in this case, plus 9v, that's called descending order, the second power, this is an invisible or an implied first power, plus 18, that's my zero power, so to speak. V to the zero power is 1, 1 times 18 is 18. There's my equal sign there, and this whole side just turns into 0. So all of this is just a fancy zero. 18 minus 18, 9v minus 9v. This is 0 over here, and this side turned into v squared plus 9v plus 18. I wrote it in that order in standard form so it would be easier to factor. Now I'm going to factor this. I take the square root of this one, put it here and here. I look for factors of 18 that will add up to 9. Well, that would be 6 and 3. 6 and 3 might work, so I'm going to try it. And in order to add up to net positive 9, that's what we're shooting for here. It doesn't matter where we put the 6 and the 3. What matters is they have to add up to positive 9. So I'm going to make the 6 positive and the 3 positive. That's how they add up to positive 9. And now I've got this situation. I've got something times something else is equal to 0. That's the zero product property. If this chunk times this chunk is equal to 0, then either this chunk is 0 or this chunk is 0. Those chunks are called factors. So if this factor is 0 or this factor is 0, I've got two situations here. Either v plus 6 is 0 or v plus 3 is 0. Okay. Because if two things multiplied together equal 0, then either the first one is 0 or the second one is 0. And that's exactly the situation I've got here. So I'm employing the zero product property. Now I just have a simple algebra 1 or pre-algebra equation. I'm just going to subtract 6 from both sides, rewrite my equation, v is equal to negative 6, or subtract 3 from both sides on this one, v is equal to 0 minus 3 is negative 3. Those are my two solutions. You could write your solution like this. Oftentimes you'll see it written in set notation. Okay. And it doesn't matter which one comes first. Either one of them could be listed first. Okay. So that is how we solve a quadratic equation by factoring. We have to make sure that one side of the equation is set equal to 0. Make sure that your quadratic term is positive. Factor. And then employ the zero product property. Okay, I'm going to do another one here. I want to set this side of the equation equal to 0 because I want my k squared to remain positive. So I'm going to subtract 30 from both sides. I'm going to rewrite my equation. This is k squared minus 1k, there's an implied 1 there, minus 30 is equal to, and this of course cancels out and gives me 0. And so now we've got our quadratic equation set equal to 0, so I'm going to factor. Square root of this one, here and here. The factors of 30, that's numbers that will multiply together to give me 30, and those same numbers will add up to 1. There's an implied 1 right there. Okay? And those numbers would be 5 and 6. 5 times 6 is 30. 6 minus 5 is 1. So I'm going to use 5 and 6, and it doesn't matter where I put them. I could put the 6 here and the 5 here. What does matter is that they have got to add together to give me negative 1. That's an implied negative 1 right there. That minus k means negative 1k. So I want these two to add up to negative 1, and the only way that can happen is if the 6 is negative and the 5 is positive. Now I've got my quadratic trinomial that's set equal to 0 factored. Once it's factored, I can employ the zero product property. If these two factors that are multiplied together, if this times this is 0, then either this factor has to be 0 or this factor has to be 0. So I'm going to say, well, either k plus 5 is 0 or k minus 6 is 0. Now I solve both of them. In this case, I'll subtract 5 from both sides and get k is equal to negative 5. Or I add 6 to both sides. K is equal to positive 6. And those are my two solutions. We could leave it like this, or oftentimes you'll see it written in set notation. The set whose members are negative 5, negative 6. Okay. I'm hoping that sort of makes sense. What we're doing is we're solving quadratic equations, setting the equation equal to 0, that's turning one side equal to 0, making sure that your quadratic term, that's the term that's raised to the second power, stays positive. Once we get one side set equal to 0, we factor the other side, employ the zero product property, and solve. That gives us two values of k in this case that will make this equation true. Two values of v in this case that will make this equation true. Solving quadratic equations by factoring. Let's take a look at a couple more. I want to leave my x positive, so I'm going to add 13x to both sides. I want to turn one of these sides into 0. I'll turn this one into 0 by just adding 13x. As soon as I do that, this is 0. I have to add 13x to this side just to stay in balance. When I rewrite this equation, I'm going to put it in standard form. X squared plus 13x plus 42. That's said to be descending powers. Second power, first power, and there's an x to the 0 power there. It's implied. You don't see it, but it's there. X to the second, x to the first, x to the 0. The powers are descending. The powers are getting lower. On this side, I just have 0. Once I have my quadratic equation set equal to 0, I'm going to factor the quadratic equation. Take the square root of this one, put it here and here. Factors of 42 that add up to 13 would be 7 and 6. 7 times 6 is 42. 7 plus 6 is 13. Where I put the 7 and the 6 doesn't matter. What does matter is they must add up to positive 13. And therefore, they both have to be positive. Now I've got this factor times this factor is equal to 0. So I'm going to employ the zero product property. If this times this is 0, then either this factor is 0, and I'm going to write that, or this factor has to be 0. And we have two simple equations to solve. Scoops this over this way. There we go. Subtract 7 from both sides yields x is equal to -7. Subtracting 6 from both sides yields x is equal to -6. Those are my two solutions to this quadratic equation. Both of these values will make this true unless I made an arithmetic mistake. Those are my solutions right there, and you will often see them written in set notation. The set whose members are -7 and -6 are the solutions to this quadratic equation. Okay? Let's take a look at one more. Here's a quadratic equation that only has two terms, and I want to keep my quadratic term, that's the term that's raised to the second power, positive. So I'm going to subtract 7n from both sides because that will turn this side into 0. I want one of the sides to be 0. So I'm subtracting 7n, rewriting my equation. I got n squared minus 7n on the left side of the equation. On the right side of the equation is 0. Now I've got this thing equal to 0, I want to factor. Well, this is not a trinomial, it's a binomial. So I'm just going to look at it and ask myself, well, is there anything that both of these have in common? And there is, they both have an n. So I'm going to write down the n, open a parenthesis, and then term by term, divide each term by n in my head. I ask myself, well, if I pull an n out of this term, dividing, I'm left with the other n, right? And then on a quick check, n times n is n squared. Minus, what do I pull, if I pull the n out of this, what's left? Well, that's the -7 there. And I close my parentheses, equal to 0. And then I do a quick check. N times n is n squared, n times -7 is -7n, so I've got it factored correctly. And now I'm going to employ the zero product property. If this little bitty factor times this big factor is equal to 0, then either this little bitty factor is equal to 0, or this bigger looking factor is equal to 0. Then I solve them both. Well, this one's already solved, okay? So there's nothing else we need to do there. This one, I have to add 7 to both sides. So I add 7 to both sides. And I get n is equal to 7. By already solved, it means that I mean that n is already by itself, okay? So here we go. These are our two solutions, our two roots to this equation. The solutions are referred to as roots often. And we can write the solutions to the equation like this, or we can put them in set notation. Either 0 or 7 can be plugged in here and make this equation true. Unless I've made an arithmetic mistake, and I hope I haven't. I hope that makes sense. The whole idea here is to set your quadratic equation equal to 0. Once one side of the equation is equal to 0, factor the other side, and then say, well, if this times this is 0, either this one has to be 0 or this one has to be 0, and solve. And that's what we've done. I hope that makes sense. Best of luck.